So doing proofs with angles, they introduce a lot of different types of angles and angle relationships here. And if you look at this box, they have these definitions that tell you kind of relationships between types of angles. The first relationship that they talk about is what's called a linear pair. Just like it sounds, a linear pair forms a line. Okay, a linear pair forms a line. It is also called a straight angle. They are adjacent angles, meaning they are right beside each other. So adjacent means they are beside each other. And the angles form a straight angle or a line. That is a linear pair. A linear pair. Vertical angles. Vertical angles are angles that are formed by two intersecting lines, okay? And they are the opposite angles, not the linear. You can see that these intersecting lines form linear pairs. 3 and 4 would be linear, 4 and 5 would be linear, 5 and 6. But vertical angles are the ones that are opposite of each other. So 4 and 6 would be vertical angles. 3 and 5 would be vertical angles, all right? So vertical angles are formed by intersecting lines, and they are the non-adjacent ones. The adjacent ones would be a linear pair. The non-adjacent ones would be a vertical angles. And then they introduce complementary and supplementary angles. Complementary angles add up to 90 degrees. They are called complements of each other. They can be joined, like they can be adjacent with a common side, or they can just be two separate angles. But as long as their measures add up to 90 degrees, they are called complements of each other. The other ones are supplements. Supplemental angles are angles that add up to 180 degrees. Again, linear pairs, those would be automatically supplementary angles because a linear pair forms a line. A line is 180 degrees. But they don't have to be adjacent. They can be two separate angles that add up to 180 degrees, and they're still considered supplementary. Still considered supplementary. All right. So let's look at, we're going to flip over to page 92 just to look at some examples of these. Just some examples of these. They have this figure here, and they want us to name two adjacent angles. Adjacent means that they are side by side and they share a side. So if we were looking for adjacent angles, there's several examples here. If we looked at angle FAG right here, that would be adjacent to AGC. That's an adjacent angle. This one would also be adjacent to EGF. Adjacent just means they are side by side and actually have a common side. Adjacent just means it's right next to each other with a common side. So any two of these would be adjacent angles. If we wanted to look at angle DGC here, angle DGC, that would be adjacent to BGC or to GD. All right? So adjacent just means side by side, and they share a common side. So we have a common side, then they are considered adjacent. This is adjacent to this. All right? Adjacent. Next, they want us to look at angles that are supplementary. So remember, supplementary means they add up to 180. A lot of times people will remember the difference between complement and supplement. Complement, corner. So at a corner, you would have 90 degrees. Supplement would be 180. They want supplementary. And so if we want supplementary angles, we want angles that add up to 180. That add up to 180. And so remember, they don't have to be side by side to do this. So if I know that this angle here, EGD rather, is 90 degrees. And how do I know that's 90 degrees? How do I know this one is 90 degrees right here? Yeah, it's got this little notation in the corner there. So anytime you see this notation right here, it's 90 degrees. All right, it's 90 degrees. Now we just discussed that vertical angles, right? Vertical angles are opposite of each other. Some interesting fact about vertical angles that we're about to discuss in our handout is they are also congruent. So this guy is also 90 degrees. So that means these two here would be supplementary. Supplementary. All right, 180. Look at the next one, complementary. Complementary means they add up to 90. Do you see two angles that add up to 90 here? Two angles that add up to 90. Yes, we have this angle right here. This angle, FGA, and then BGC. You see those two measurements there? Add up to 90. So these two angles would be complementary. Complementary. Right? So you need to know how to find those. Know how to find those. Let's look at your handout now. All right, so the first thing you'll notice at the very top of your handout is properties of equality. This is just reminding you what we've already talked about. Properties of equality. You will be using some of these properties as we do these proofs. Addition properties, subtraction, multiplication, division, distribution, substitution, reflexive, symmetric, and transitive. And then properties of congruence. Reflexive, symmetric, and transitive also work for congruence. Then we get into some definitions here. The first definition you should be familiar with just from our segment. It works with angles as well. If the measure of angle A equals the measure of angle B, then angle A is congruent to angle B and vice versa. And so there will be times when you have to convert from congruence to equality so that you can add and subtract, because those are all properties of equality, the addition and subtraction. And then you may have to go from equality back to congruence if that's what you're trying to prove. All right, the next one that they talk about is definition of angle bisectors. So this is actually in section 8 of your book, but we're going to cover it now because you use it in these proofs. An angle bisector cuts an angle in half. It cuts it into two equal angles. A segment bisector does the same thing for segments. So an angle bisector cuts an angle in two congruent angles. An angle bisector is a ray, or it can be a line, all right? Whereas a segment bisector can be a point or a line. So an angle bisector cuts it in two equal parts. Complementary angles we talked about. If they're complementary angles and their sum is 90, you notice that little double arrow here? That means it works both ways. If the sum of the angles is 90, then they're complementary. Sometimes in a proof, they will tell you that angles are complementary, then you know that they add up to 90. Or sometimes you'll be trying to prove that they're complementary, and you'll get to that they add up to 90, and then you can say, well, then they're complementary because the definition of complementary. Supplementary is the same, except it's 180. And then perpendicular. Definition of perpendicular. Perpendicular lines form right angles. Okay? So this is a definition that you need to know. Definition of perpendicular. Perpendicular lines form right angles. And then what is a right angle? Well, a right angle equals 90 degrees. Okay? So these are all things you're going to have to use for these proofs. The second half of this page are theorems and postulates. So the first one is angle addition postulate. Let's talk about this. All right, we actually use this in the last chapter, right? Angle addition. And so now we actually have a name for it. Angle addition postulate is that the sum of the two angles add up to the larger one. So if you have two adjacent angles like this, you can add the two smaller ones and it will equal the larger one. We've already done this, but now we're going to use it in a proof, okay? We've already done this process, but now we're going to use it in a proof. All right, so these are all new theorems for you. Definition of vertical angles we talked about. Remember, vertical angles are those that add up, or that are vertical formed from intersecting lines. So like in this case, angle 1 and angle 2 would be vertical angles. The theorem tells you that those are congruent. So if you know the measure of angle 1, it is congruent to the measure of angle 2. All right, if you know the measure of angle 1, it's congruent to the measure of angle 2. Complement theorem. This is different than the definition of complements. Definition of complements means they add up to 90 degrees. The complement theorem says that if they form a right angle, then they are complementary. So if two angles form a right angle, then they are complementary. This seems logical, but you would have to go through the process of saying that if this theorem wasn't here. You would have to say, okay, they add up to 90 degrees. From the angle addition postulate, that means the larger angle is 90 degrees. From the definition of right angle, it means that it's a right angle. And then you could say that they're complements, so they make a right angle. You don't have to do all of that. This theorem has already been proven. The same thing with supplement. If they form a linear pair, then they are supplementary. So like in a proof, if they said, these two angles are a linear pair, you could tell me that as given, and then the very next step, you could say they're supplementary because of the supplement theorem, all right? And so then you could use them, that they add up to 180, and you could go on from there. So linear pairs are supplementary, is the supplement theorem. The next two talk about congruence. If you have two angles that are complements of each other, like A and B, and then you know that C is congruent to A, then you can say that C and B are complementary, and vice versa. If A is complement to B and C is also complement to B, then you can assume that A and C are congruent. All right? So if you have two angles that are complementary to the same angle, then you know those two angles are congruent. And that's true for supplement as well. If you have two angles that are supplementary to the same angle, those two angles are congruent. And it makes sense because they add up to 180. And they're adding up to 180 with the same angle. All right? So these are all theorems that we're going to use as we go through these proofs. If angle A is a right angle, then the measure of angle A is 90 degrees. What tells us that? Definition of a right angle, right? Definition of a right angle. All right, let's look at the next one. If X is supplementary to Y and X is supplementary to Z, then Y is congruent to Z. Yeah, the congruent supplement theorem. All right. What does that picture tell us about angles 1 and 2? What type of angles are they? What type of angles are these based on this picture? They are congruent, but why do we know they're congruent? They're vertical angles. So these two are vertical angles, all right? If they're vertical angles, then they are congruent. So that is the vertical angle theorem.
Why are they called vertical angles?
All right, so vertical angles theorem. All right, 4. If measure of P plus measure of Q equals 90, then they're complementary. That's just definition of complementary. Yep, definition of complementary. 5. If M and M form a right angle, then they are complementary. This is actually the complement theorem. It is different than like the congruent complement theorem. This is just the complement theorem. Complement theorem. All right, given this picture, if L, and that symbol means perpendicular, if L is perpendicular to M, then angle 1 is a right angle. If L is perpendicular to M, then that's a right angle. What tells us that? That's definition of perpendicular. Definition of perpendicular. Number 7, if W and X are supplementary, then the measure of W plus the measure of X equals 180. That's just definition of supplementary. If angle L is complementary to angle M and N is complementary to angle M, L and M are congruent. That is the congruent complements theorem. Yep. If angle A and angle B form a linear pair, then they are supplementary. That's the supplement theorem. All right, look at the next one. If N and P are complementary, then they add up to 90 degrees. That's just the definition, right? Definition of complementary. Given this figure, they're telling us that JKM plus MKL equals JKL. What tells us that? Angle addition. You're going to use that one probably as much as you use segment addition when you did those proofs. All right. Angle addition postulate. If the measure of R equals the measure of S, then angle R is congruent to angle S. Yeah, you've used this a lot too. You'll use this a lot when you do these proofs. Definition of congruence. So let's look at number one together. Just like in any proof, you want to figure out what you have and what you're trying to get. All right, so they've given us that PQR is a right angle. So I want to look at this figure and I'm going to say, which one is PQR? Well, PQR is this outside angle here, PQR. So they have told us that this is a right angle. We know that this angle here is a right angle. They want us to prove that PQS and SQR are complementary. All right, so now I'm going to say, well, what am I trying to prove? I'm going to try to prove that these two angles here are complementary. And so I want to think about what's the definition of complementary. What do those two angles have in common, or what do they do? All right, how does that help me with what they've given me? So let's just logically walk through it before we actually look at their proof. They have told us that this large angle is a right angle. I know that these two smaller angles should add up to this guy. Why do I know that? Why do I know that two smaller angles add up to the whole angle? What tells me that? Two of the smaller pieces add up to the large piece. What tells me that? Angle addition. Two smaller angles add up to the whole, angle addition. Well, these two add up to the whole, and the whole is right angle. Well, then what does the right angle mean? What does that mean if it's a right angle? It's 90 degrees. So now I know that the two angles add up to 90 degrees. I know that probably by substitution, something like that. All right. Well, if they add up to 90 degrees, that is the definition of complement. And so then I can say, well, yeah, they're complementary. All right. And so that's the thought process you want to think about as you go through these proofs. What do I have? How does that help me? Based on what I can see, how does that help me? And how do I get from what they've given me to what they want me to prove? So let's look at the steps they took to do this. The very first step, that's very simple. First step says PQR is a right angle. How do I know that? That is given. All right, so that one is given. All right, the next thing they did is they said PQR equals 90 degrees. How do they know it equals 90 degrees? Yeah, the definition of a right angle. The definition of a right angle tells me that it adds up to 90 degrees. Let's look at the next step here. The measure of PQS plus the measure of SQR. So PQS plus SQR equal PQR, the whole. That is angle addition postulate. All right, angle addition postulate. Now they have said that PQS plus SQR equals 90. What did they do here? We don't know that they're complementary yet. What did they do here? We have that PQR is 90. We have that these two parts equals PQR, and now they're saying these two parts equal 90. What did they do? Yeah, substitution. And I would actually take transitive there too, because you could say that this equals the PQR, PQR equals 90, so this equals 90. So I would take either substitution or transitive there. Substitution or transitive there. All right? And so yes, from this step, the two angles add up to 90. So then how do we know that they're complementary? That is definition of complementary. If they add up to 90, then they are complementary. And so this last step would be definition of complementary. The first one, angle 2 is congruent to angle 3. How do we know that? That is given. That is given. Angle 2 is congruent to angle 3. Then they told me that measure of angle 2 equals the measure of angle 3. How do I know that? Definition of congruence. One and two form a linear pair. How do I know that? That's the other part of my given, right? Now, they said angle 1 and 2 are supplementary. Based on that first page, what tells you that linear pairs are supplementary? The supplement theorem. The supplement theorem. If they're supplementary, then they add up to 180. What tells me that? Definition of supplementary. Now they're telling me the measure of angle 1 plus the measure of angle 3 equals 180. Why can they do that? That is substitution. Substitution. If measure 1 adds up with measure angle 3 to 180, how can we then say that they're supplementary? That is actually the definition of supplementary. Definition of supplementary. All right, so number 4 says, given that ray BE bisects angle ABD, and that BD bisects EBC, prove that ABE is congruent to DBC. So, let's first see what they have told us, all right? They've told us that this ray, BE, which is right here, bisects this large angle. What does that tell us about the two smaller angles? This one bisects ABD, what do we know about these two angles? They equal each other because of the word bisect, all right? They've also told us that BD, this one right here, bisects this one. So what do we know about these two angles? They equal each other. So these two angles equal each other, and these two equal each other, and we're trying to prove that this guy over here equals this guy over here. That seems logical that they would, right? Okay? But we have to prove it step by step. So anytime you're given a word like bisects in your given, you are going to want to use the definition of that word somewhere, okay? So that's just a clue that somewhere you're going to use definition of that word, all right? And so they start out simple, as always. BE bisects ABD. We know that why? That's been given to us. They have then told us that those two smaller angles equal each other. Why do we know that? Definition of a bisector. Definition of a bisector. All right? So they've told us that ABE is congruent to EBD. That is definition of a bisector. Definition of an angle bisector. All right? Now they've told us that BD bisects EBC. How do we know that one? That's also given. And then they've said exactly the same thing about the other two pieces. They've told us that this angle here is congruent to that angle there. Same reason. Definition of a bisector, right? All right, so now we went from, look at what they did. They said that ABE is congruent to EBD. And EBD is congruent to DBC. So therefore, ABE is congruent to DBC. What property says if A is congruent to B and B is congruent to C, then A is congruent to C? Transitive property. Transitive property. This is congruence, you want to just use transitive here. So this is going to be transitive. Substitution is an equality property.